Here.
Alexander Schenker. Jimmy Wang. Liang Wang. Wenji Wang. Si Jian Shu. Ji Chao Zheng.
Here.
Have I not called anybody? All right, we're going to get started. This is here. I'll upload the slide later. Okay. So this is a CCI 655 assembly language. I can read.
Good try. Logging into room.
How to sign the username?
You want to sign in through your account?
I want to open this and how to open this computer?
Oh, you have to use your FDU ID.
Oh, okay.
Who just came in? Me. What's your name?
G-O-L-I-N-G.
All right, so yeah, this is CSCI 565 assembly language, 1225. People review, so I'll be teaching class 3 years. So syllabus, let's review the syllabus together first. Before I do that, if you actually go to the web campus, there's an announcement. You gotta join what's called EdSTEM, okay? If you don't join it, you're not gonna get any information from me, okay? I'm posting everything there. Web campus is just for the sake of solution. Okay? Here's the syllabus. All right, so we're gonna be meeting 3:15 to 6:15 every Thursday, yeah. Every Thursday. Hope you're in the right class. Okay, good. So you can contact me via email, but I'm going to tell you some communication protocols that I want to do. Land acknowledgement, you can read it. So this class, we're going to be learning the assembly and C programming, all right? So first, we're going to start off with the assembly, and then we're going to go down to C. We're going to go a bit of a computer organization in terms of the what do you call it, CPU processor organization. So we're going to learn that along the way. We're going to use the assembly language called MIPS, all right? So that's what we're going to use. Textbook. I talked about it. You must purchase the textbook for this course, okay? You don't have a link yet. What I'm going to do is that tonight, I'm going to post homework 1. If you click that link, it's going to take you to the textbook website. You have to purchase it there. You have to purchase it from the link that I provide you so that your name is linked to my web campus, okay? You're going to be doing all the quiz, all the homework on that textbook, and when you finish it, the grade is linked directly back to the web campus. So if you don't buy from that link, it's not linked at all. Okay? So that's the requirement. There's a recommended textbook as well, but again, just don't wait for it. Probably tonight after dinner, I'll post a link, and then that way you'll be able to get it. I think grading policy. So this class will have 4 components. Homework is basically you have to read the textbook. All right. So I'm going to give you homework is going to be linked to web campus. You have to do it by deadline. And you have to do it because it's basically tracked by the backend ebook server. So you actually have to do it. You have to do the activity. You have to do all of that. Okay. Nice thing about the homework is it's a completion based. If you complete the activities, you get the points. That's it. Okay. There's no grading on it. The quiz is different though. Okay. Quiz is I'm gonna talk about that. Every week you're gonna have a quiz on your machine. Okay. And that's actually graded. So you can get like 8 out of 10, 9 out of 10, or whatever. Okay? That's 30%. We have one midterm exam in the middle semester and one final exam at the end of the semester. All right? So that makes it 100% of the grade. Okay. The grading schema is here. You can take a look at it. Course schedule is something that I want to talk about it. Okay, so this is going to go through the book chapter. So we're going to go start from the the data representation in bits. Assembly language into it, and then you're going to get a file recess, list assembly, and then midterm. And after that is all about processor and C. That's how the processor, C, and the memory. Okay, so second half of the class is going to be done this way. The nice thing about this ebook that we're going to be using is everything is open. Okay, if you want to learn ahead of time, you can do it. I cannot hide it. Okay, you want to learn like today's test. You want to finish like all of this, you can finish if you want. I don't care. Okay. The textbook is designed so that you can go ahead if you want. What that means is homework 1, 2, 3, 4, whatever. You can finish all of this if you want. Okay? I can't hide it. Only thing that you can't do it is the quiz. Okay? Which is something that I'm hiding it. Okay? Again, homework is all about completion. Okay? You read the textbook, you do the activity, you're done. Okay? So the textbook has chapters 1 to the actual textbook has up to chapter 8, but I got rid of the last 2 chapters, so we only have 1 to 6. We're going to have one recess class here. Luckily, because the fall recess, we don't have a class that day. And I don't think we have any other holidays because it happens to be Thursday. There's a reading day, obviously no class, okay? We just follow the homework schedule. So basically, I'm going to assign homework 1 today, and then that's due next week. Probably going to be Wednesday, 11:59, okay? So always 11:59 before the class, that's due. You can do it if you want, whatever. As I said, you'll be able to see it when you purchase the textbook. All right, that's everything with a date. If you have questions, you can ask in the assembly later. I'll talk about the quiz a little later. Okay. Resource, whatever available, you can take a look. Okay. University policy, I think we all know. Withdrawal. I think you should know your withdrawal date. Okay. So that's all. I don't know the date. You have to refer to bank or academic calendar. All right, so that's one. And then now, let me just talk about the EdStem a little bit, because this is something that I want to show you. All right, so EdStem is basically a discussion platform. So, yeah, there you go. So you're not going to see all of this. You're only going to see as a student 3 things. You have a 5.65, and then announcement, course document, and discussion board. As you know, the syllabus is already linked to the course document. Anything I use, I'm going to use the slides today to explain some concept, right? Not concept, but the slides explain the logistics of the course. Then it'll be uploaded on the course document. Any announcements that I post, I'll post it here, and you're going to get an email. You're never going to get an email until you sign up. Okay, and then I'm going to send I'm going to post one announcement regarding homework 1 and textbook purchase today. So sign up. You should have received the invitation. If you haven't received the invitation, email me. And discussion board is where you basically ask questions to me or each other. We'll talk about that a little more about the communication protocol. All right. So with that, we're done with the syllabus. The textbook. All right, so you must purchase a textbook for this course. There's no way you can get by. And you should only purchase a digital textbook. All right? There will be a homework 1 on the webcam tonight. I'll post it. And then it's going to be very obvious. You click the link. That link is going to take you to the textbook. I'll post this on the EdStem, by the way. Okay? All the slides will be posted on EdStem. The homework 1 will be on your campus. You click that, it's going to take you to the textbook, exact textbook website. You have to sign up there and you purchase textbook, and it unlocks everything for you. Okay. So chapter 1 is free. Don't do the homework before you purchase the textbook, because you must sign up purchase the textbook so that all your data is linked to the web campus. Chapter 1 is free. If you do it, your grades will not get sent back to back to a web campus. Okay. So you only do the homework after purchase, all right? And then also do not purchase outside of web campus, because IT and I worked on this. If you purchase directly on the vendor, it's same price whatever, but the thing is your information is not linked. Okay, that's one. Homework. So the textbook is called Zybus, okay? So that's a vendor. It's from Wiley. There are mainly 2 activities that you have to do. So you read, we're going to do it together actually, because the way the textbook is, well, this textbook is actually designed by a computer science professor, so it's meant to be used this way. So I don't have a separate slide. What's happening is, your textbook, when I click the presentation mode, it converts into presentation mode, and I'm going to use that to teach. So whatever I'm teaching is basically whatever's in the textbook. And whatever activity I'm going to do is going to be whatever's in the activity. However, you must do the participation activity and challenge activities, okay? Behind the textbook, there's a data analytics server engine running. So if you don't do it, it tracks it, and I get the report. Okay, so it does require you to read it and then do these 2 activities. Participation and challenge activities, I made it setting so that you have a limited chance. You can keep doing it. You get it wrong, do it again. I don't really care. That's the purpose of you just understanding it. Okay? Deadline will be visible once I set it up. It's going to be obvious when I set it up. Okay? Okay, as soon as you purchase the textbook, you have access to chapter, whatever, all chapters. So you can read everything. All right, quiz schedule is on the syllabus. Okay, this is something I'm sure you guys care more. All right, so there are going to be 2 types of quizzes. Sometimes the quiz is going to be multiple choice, which is going to be the case for next week. Okay, next Thursday we have a quiz already. Okay, on the homework 1. All right, and then sometimes it can be coding. All of that will be done on Zyba. Okay, which means but it's a closed book. Okay, you can't use anything else. You just have to use it. And I'm going to be watching your monitors. Based on previous week's lecture, so today is going to be lecture 1. The quiz next week is going to be on lecture 1. Only on lecture 1. And I tell you, there's no coding next week, okay? Sometimes there's coding, I'll let you know. The coding is only going to happen when you get to the assembly language or C language. Until then, we're not going to have it. Always last hour of the class. All right, so the lecture is going to be 2 hours. I'm going to teach you from 3:15 to 5:15 with a break in the middle. And then from 5:15 until whenever the class finish, that's when you do the quiz. Okay? And next week is going to be easier, obviously, because it's easier concept, and then it's a multiple choice. But there are some times the MCQ is going to be longer, or the coding is actually quite expensive. I'll let you know every week. I'll let you know there's going to be a coding or it's going to be multiple choice quiz next week. Okay? Just like I said, next week is a multiple choice. It'll be timed and auto-graded. As soon as you finish here and get out, you're going to see the grade right away. Okay? So expect that. That's why I say 1 hour. After 6:15, the quiz closes, you're done. I don't control this, okay? I mean, don't come to me and say, oh, this is me, whatever, okay? It's your responsibility. Submit it on time. All right, we have 2 exams in this class. We have midterms and finals. Midterm during class time, so basically whatever midterm time that we scheduled on the syllabus, that's going to happen, like here, okay? And then the final exam should be on the school schedule sometime. I have no idea when, okay? So when they post it, we will post it. All the exams close everything, okay? You're not going to get anything. All right, just do the exam, that's it. And it's going to be multiple choice and coding as well, okay? So expect that. Okay, so communication protocol is something that I want to talk about. Maybe I am a bit different from other professors at DU. So I'm going to go do it this way. So join the STEM, that's the requirement. I mean, you don't have to join if you don't care, okay? So, but join it. Don't email me unless it's personal matters, grade related, or something that requires confidentiality, okay? So say you're sick and whatever, email me, that's okay, okay? Or somebody dies, okay, you have to whatever, email me. But anything about, oh, is the homework due next week? I'm going to ignore your email, okay? I already have my email filters, so that's fine. All right? It should be obvious, unless it's confidential, grade related, don't email me, post it on the essay. If the email is needed, write your name and the class name using FDU email. And if you use ChatGPT and have this kind of stuff, I'm not going to even care, okay? So if email is not following protocols, I'm going to filter it out because already I have a filter. You know, those emails go to my junk, not junk, trash. So be clear on this. I get enough emails from everybody, so this is a protocol that I came up with and follow this. Another reason about the STEM is I think if you post your questions there, other students can see it, so I don't have to answer the same question 20 times. All right, so miscellaneous, no late submissions. It's obvious. What do you have to submit here? We have quiz, homework, quiz, exams. That's it, right? We have nothing else. That means everything is digital, and you submit it online. And don't tell me that, like, okay, like I could submit it. Obviously, you wait until the last minute, then you try to submit it. There's a server load. You're not gonna do it, right? Any sort of examination, you have to submit it. Even 1 second late, you're gonna get 0. Okay, that's a policy, and it's stated here. I'm not gonna change it. Okay? Like I don't understand why something is due 11:59. I don't know why somebody clicks the submit button at 11:59. That's just stupid, I think. Okay. So anywhere in your life, I think. Apply to your job that way. Okay, you'll see what I mean. All right, deadlines are all automatically set and recorded. So that means all the deadlines of submission time and the date will be on your web campus. Okay, it's going to be very obvious. All right. Okay, unless few things, medical emergencies, circumstances that prevent you from online submission, and things happen in life. Okay, so email me in this case. So don't think like, okay, I'm not gonna get any late submission. Obviously, as I said, car accident or something happens, whatever, email me. I know enough things like this happening actually. Okay, not everybody. Every semester I get email, and this email I'm gonna ignore. Don't ask me for extra assignments to increase your grade. Okay? You're gonna say, oh, I now understand. Can you give me some extra assignment? No, I don't have time for this, and you don't deserve this either. Okay? Whatever grade you get it is whatever grade you get it. That's to be fair. All right. So that's what I'm trying to say. Okay. Don't ask anything extra. Everybody's fair here. You get one chance on the exam, one chance to find, and that's it. All right. 2 things. Class attendance. I'll be very clear on this. I don't really care. You learn your stuff. Okay. You came here. You come late. I don't care. Okay. You come leave early because of your kids or you have other events. You have to go now. Just go. I don't really care. All I'm trying to tell you is, class happens 3:15 to 5:15. That's a lecture. 5:15 to 6:15 is a quiz. And however you want to use it, I don't really care. You can come in for 5:15 for the quiz. That's fine. Okay? Yes, there's attendance policy, but I'm only going to take the attendance today and the next week because of this. I have to report it because of visa. Okay? Again, this is all your learning. The master's, you're only masters, right? So as I said, you do any way you like. Okay? I mean, I saw some people the SkyTrain was late and trying to get. I don't care. Just be late. Okay? All the textbook stuff I'm using it is there, and it's your thing. Okay? I know many people stuff happens. Okay? But regarding the grade and the quiz, I'm not going to take the excuse unless it's really something academic, unless you're sick or got accident or something I have to accommodate. If you're late for the quiz and whatever because you're just being lazy, I'm not going to do anything, okay? By the way, I know you can take the quiz at home because all digital, but I will monitor the IPs as well as, I know some people try this VPN, but I know how to track it. I all set up in the backend server, so you do have to take quiz here, okay? Because I know people try to do it. And if you do that, you're going to get 0, and I'm going to report it. Yes?
Is it allowed to do it on our own computer, or it has to be a school computer?
Midterm and the final, school computer. Everything else I don't care. All right. Okay? So that's the thing about this class. I mean, this is my policy, my own policy underneath the school, okay? School expects you to do it. You have to attend it, yes. But things happen in life, and this class time and this message, as I said, it's your own learning. Come if you want. not one. Come if you, you're gonna learn, but things, prevent you from coming. I'm okay. I'm not that crazy. Okay. AI used in class, right? I don't care, to be honest, but you're not gonna be able to use AI in the quizzes and exams. Okay. So quizzes and exams, if you get caught using AI, you're definitely gonna get reported. And I'm very good at this. Okay, I caught somebody every single semester in my career, almost except one. So, but right now today, you all use AI, whatever. Use translating function, learn something, ask me. I don't care. Okay, just do whatever you want to. But you can't use it for quiz and the what do you call it? Exams. The exams, yeah. Whatever this activity challenge, you can use it. I don't really care. Okay? It's fine. That's it for logistics. Any questions about the class logistics? Because I'm gonna start. All right. So this is how the textbook's gonna look like. So I am in the presentation mode. So when you get in there today, it's gonna be like a textbook like this, okay? But I'm just using a presentation mode to do it. You don't have to do presentation mode, to be honest, okay? And the thing is, whatever I see it, tonight when you purchase the textbook, you're gonna be able to see the same thing, okay? So it's whatever. Okay. So this is assembly class. Let me tell you a little background on myself, and then what this class is about. So, I did my studies all in the States, and my actual research, and then the research interest in my PhD is what's called computer architecture. So, where people like me work is Intel, AMD, Apple, and NVIDIA, pretty much. Okay. What we do is we design processors. So that's what computer architects do. That's what we are called, computer architects. We design GPU chips, we design CPU chips, right? And where it's going to be a cache, how we design the cache and stuff. My expertise was on memory systems, okay? So where this class fits is the machine doesn't understand the C code, Python, Java. Right? Machine talks in machine language, and then machine language is just basically one thing, 0 or 1, right? You have binary code, right? 1 0 1 1 0 0 1 1. That's the machine code. But it is extremely difficult to code it that way, right? So there's something called assembly language, which is each company has their own assembly language. Not each company, each processor vendor, maybe. And that is one of the very first computer languages out there. Okay, before C, before C++, Java. It was assembly language. That's how things got evolved. Popular assembly language you're going to hear are x86. I'm sure you buy Intel machine, it's called x86, x86 64. That's assembly language, okay? That's Intel AMD. Apple, your processor is what, M4, whatever, M3 these days, right? They use ARM processor, their assembly language is called ARM, okay? NVIDIA's assembly language is not called CUDA, okay? CUDA is not assembly language, okay? It's called something else. And there's something, NVIDIA is a little different the way they run it, okay? There's something, some of you might have heard about called PTX, that's also not assembly language. Anyways, that's assembly language. And then, still quite complicated. We're going to learn assembly language and we're going to see that it's going to be not as easy as C or C++. And then after that, the language out there is C, which is not object-oriented language, okay? I think you're going to, I don't know if you know this, but you heard of logic-oriented language all the time, right? So, object-oriented language was not C. C was C. And then people came up with C++ because object-oriented is better. And C++ was still hard, people came up with Java. Java is still hard, people came up with Python, and these I don't know what. So that's how we started. Okay, this is computing language. Okay, you start from all the way Python, Java, C++, C, assembly, and then the machine code. Okay. So obviously, where we're going to start is we are going from bottom up. We have to start with the machine code, and then I cannot just keep dump you with like a 0, 1, 1, 1, 1. So you have to understand what this 0, 1, 1 means to a computer, right? And the very first thing that we gotta do is we gotta understand data representation, okay? How are you gonna represent alphabet A in a computer? How are you gonna represent number 1 in a computer? That's what we're gonna start off. And then after that, we're gonna learn assembly language, I guess. And then later in the semester, we're gonna learn C. Okay? So that's why we have something called the ASCII and Unicode. Okay? I'm sure you all heard about it. Bit is a 0 or 1. That's it, right? That's a representation. So if you actually check your internet provider, I'm sure you pay like $1,500 for like 300 gigabit, whatever, right? It says, I'm pretty sure almost all of you is 150, 300 or whatever giga small b per sec, okay? Because the unit there is a gigabit per sec, okay? However, when you buy a MacBook or this kind of computer, you buy a memory, right? And then if you look at there, the B is actually capital B. And that's a megabyte, all right? So byte is 8 times bit, all right? So I have 1 megabyte. That means it's 8 megabits, all right? So your internet is 150 megabits, right? That's actually at the end is 20 megabytes. Every file system you see it is going to be some bytes, okay? Megabytes, kilobytes, gigabytes, bytes. So you understand why your internet sucks, right? Your internet, you pay 300 megabits divided by 8. That's the actual speed of the file transfer you're talking about, okay? So you download like a movie, that's like what, 2 gigabytes or something like that, right? And then you transfer over like gigabit internet. Obviously, it's not 1 second, right? That's the reason because it's actually just divided by 8. So that's the difference between the bit and the byte. And then we have something like characters. Everything is a character on your keyboard. Nothing is a bit or a byte, okay? Number is also a character, okay? Everything is a bit of a character, just different characters. We have numbers, alphabets, symbols, and a single digit like that, okay? Everything is a character. And that's going to tell you something because the computer doesn't understand the character. We need a representation of a character that the computer can understand. And that's exactly what this is. ASCII bit code. Alright, so what happens is, if you look at this ASCII code, whatever you see on the right side is the, whatever you see on the keyboard, right? Alphabets, some symbols in the space and whatever, right? So in order for a computer to understand what you're doing, you need that to be coded, okay? And that's called ASCII coding, alright? It's ASIC. So what that ASCII code does is, you can use a number to represent the character, okay? So if we do a capital A, this is 65. Everywhere you go in the world, every computer in the world, general purpose computer, number 65 means alphabet A, okay? Small letter 97 is 97, okay? So understand the mapping there. However, this is a decimal, right? The number that we use every day. The problem is computer doesn't understand decimal. It only understands binary, which is 0 and 1, right? So how do you convert that? Well, 32, you convert it becomes 0, 1, 0, 0, 0, 0, whatever, okay? We're going to learn how to do the converting. But understand the binary decimal in the symbol. Because, sorry, character. Because every character is going to be converted to this. And if you're very interested in, your iPhone emoji also has a byte code, a bit code as well. All right? Every emoji has something, okay? That's the reason why you're able to send emoji. Emoji is not sent as emoji, okay? Emoji is sent as a binary over the network as well, okay? That's how things work. All right. So, you're going to see this kind of thing, all right? So type of character, right? And then the ASCII bit code is this, and what am I seeing? So the question here is, this is what you have to do, okay? In your homework. It's so easy, okay? ASCII number 65, so what is that? You type the answer. And then 65, you go back up there, it's a capital A. So write capital A, check mark yours up, okay? That's what you're going to do. Challenge activity. Convert the character to a 7-bit ASCII code. Hang on, 1 second. Convert the character to 7-bit ASCII code. Okay, start. It's D. It's just ASCII code. D is where? Right there, right? So it's, I'm just gonna copy whatever. Am I correct? Yeah. That's how you get check mark, okay? Obviously it looks easy, but I'm not gonna do it, okay? Like, you're stupid. You have to do all of this, by the way. You can't skip it like me, okay? Otherwise, if you skip it, your homework grade is gonna be like 900%, alright? Alright. So, one thing that I wanted to do is, this is much more interesting. Alright, so you don't understand how the binary conversion works. But, the thing is, characters are encoded and stored in the computer memory. So, you buy a DRAM, right? When you buy a machine, you buy like 8 gig or 12 gig of DDR4, DDR5 DRAM, right? That's where you pay money. And this is exactly what you're paying for, DRAM, okay? And then the DRAM stores, as a computer can only store ones and zeros. And you're gonna store 1 0 1 0 whatever like this way, okay? And then this represents capital S, this represents capital E, okay? So this is what? SC, seat, something on the space, 9A. That's how it's displayed on a computer, right? That's how monitor works. Monitor's job is displaying this, but in your computer, you're only gonna have this, okay? All that stored, okay? So each character has unique code, and the text is stored as a sequence of binary numbers. That's it. So as far as if you actually look at the computer's memory, you're not gonna see anything. It's gonna be all that. Which is the reason sometimes when you use a Windows, you see a blue screen and then sometimes it crashes and then you start seeing a bunch of ones and zeros, right? That's called memory dump. Because whatever's in the memory gets dumped onto the monitor. But it actually means all this, okay? So let's take a look. Alright, so we can see this. Memory is empty, so S goes in. There you go. What's happening here? You go 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a decimal, so we use all 10, right?
Yeah.
So we ran out of digits, so what do? Go to the next digit, right? That's why you go 1, 0, and 1, 1. That's how we count, right? 99, we ran out of all the digits, we go to 100, right? So,
is it possible to put in the...
I can't do that actually, unfortunately. Starting next week, you'll be able to have these.
Yeah.
Not today, okay? So, same thing goes on with the binary, okay? So let's take a look at the binary digit. Okay, so you understand this process, okay? So 0, 1, I ran out of number. So number 2 is binary 1, 0 because you go on to the carry, right? So that's reset the digit to 0, carry 1 to the next digit, okay? And then carry 1 to the next digit. That's how it works, right? You keep carrying to the next digit, right? That, and then I'm done, carry to the next digit and 0, right? So next number is going to be 1, 0, right? Okay, good. I'm not going to do this. Let's keep going. All right. You have to understand there are two types of binary number. One is a signed and unsigned. One thing interesting is, okay, I can tell you number 2, I can tell you negative 2, right? Because I have a negative sign, right? We don't have that in binary. Computer doesn't have the notion of minus, right? Computer can only understand 1 and 0. So, whatever I taught you right now is unsigned binary, okay? So 0 is 0, 0, 0, 3 bits. Number 5 is 1, 0, 1, okay? And number 7 is 1, 1. Easy, right? We're going to practice one number and then move on how to represent negative 5, okay? So with that, can you guys tell me this is a decimal 65? Give me the binary of this 65. Can you figure that out? So the answer is 65, right? So 1, 2, 4, 8, 16, 30, so 60. Yeah, that's it. So that's it. So 65 decimal represented in binary is going to be 1, 0, 0, 0, 0, 0, 1. Okay. Do some practice. This takes some time. Well, let you know, okay? This one is 1, right? Here's a 2, 4, 8, 16, 32, and 64, right? So you're adding 64 plus 1. That's how you make 65. So that's how I get that answer. Do the practice. You're going to have to do this for the midterm no matter what, okay? And the quiz. It's hard right now because you haven't really done it much. But just like our decimal system, you're going to get used to it. Okay, so that's fine. All right, moving on to the sign binary then. You can learn this here in the participation activity, all right? You should be able to do this work. All right, you know what? Let's one more. Try 74. Okay, so try 74. That's why you can practice this on the textbook, but right now, just the way I did it, try 74 into a binary. It's good practice. Because after this, later on, we're going to go into a hexadecimal, which is base of 16.
Can I say it?
Huh?
74, can I say it?
I haven't done yet. Hold on.
Okay. Yeah. Yeah. I mean, rubric is cheating because it's really easy when you see like that. It's
Yeah.
1, 1, 0, 0, 1, 0, 1, 0.
That's it. Because you're adding 64,
8.
8. That's it, yeah. So that's why it's at 1, 0, 0, 1, 0, 1, 0, right? So that's how you do it. It's not going to be that easy once you get hexadecimal, but it's good though. That's how you do it. And let's see if he's lying. Is it correct? 1, 0, 0, 1, 0, 1, 0. Yep, that's it. Okay, all this is available on the book, okay? By the way, I'm not getting any commission on textbook, okay? Like, it's just whatever is easy for me and then good for you. That's why we're using this textbook. Okay? I think it's better to have a textbook that you can practice this because your exam is also going to be based on textbooks. All right, let's do an addition. So another thing that I want you to do is I want you to practice using doing a binary addition. Can you see this or no? You can, right? Hey. Can you see here? No. Yeah. Okay, that's better then. Let's do an addition. Normal addition that we do as a human, whatever we do is 99 plus 1. If we add it, what happens is, okay, we only have a single digit available, but this goes over this, right?
Yeah.
So whatever's remaining is, what's the remainder? 0, right? And then you just carry 1 there. Do the same thing, nothing, just add 2. Again, same thing happens. That's why we get 100, right?
Yeah.
So with that, let's try add a binary 101 plus 1. Okay? All right, so 1 plus 1, I don't have a digit available, right? So next one's going to be 0. Carries 1, right?
Yeah.
1 plus 0, I do have 1 available. So
Yeah.
that's it.
Yeah.
And what does that mean? That is 6, right?
Right.
Yeah. Is that correct? Let's see. 6, 1. This is 1. It's 5. So 5 plus 1 is 6. That was correct. Okay? All right, good. And then another binary thing that we can do is, so what if you do the 1, 1, 1 plus 1, 1, 1? In this case, it's a little complicated. 1, 1, same thing, right? So this is the one that's problematic, right?
Yeah.
So 1, 1, 1 is basically 3, right? And what's the remainder if you divide by 2? No, remainder.
1.
1. And this obviously a carry, right? And this one, same thing, added
0.
0, 1. That's it. So this is that's binary. That's why I asked you to divide it by 2, or what's the remainder divided by 2, okay? Once you go hexadecimal, you have to divide it by 16. Okay? Good. So that's what you do. Overflow. Let me tell you what that means. Okay. So I want you to understand the concept of overflow because this is essential, I think, later, not now. Because you're going to be heavily tested on this now. I'll guarantee you that you're going to see this word minimum twice in both things. I told you you're buying memory, right? The DRAM. Okay, so you bought 8 megabytes, okay? Why do you have a 9 megabyte card? You're screwed, right? Because you don't have memory, right? It's you bought a physical DRAM, right? It's not like it expands, it's not dynamic, right? You bought a hardware, right? Well, I told you about all this machine language, right? We are storing this in a machine. And then when I say there's 8 bits, that's all we have, right? So let's assume this. Your machine it's an old machine. So you say you have 4 bits only, okay? 4 bits. That's all you have. You bought the hardware, not software. That's all you have. All right. Now I stored 1111 here in this memory. Okay. All right. And then my calculator is this. What are you gonna get?
0.
Yeah, you're gonna get 0 as an answer. Because this 1 here, you have no place to store, right? This is called an overflow. Okay. And you can actually test this. And this is one of the reasons why, if you actually go to Wikipedia, they all have this. Because every data type, you haven't learned everything, but you learned the character, right? The symbol, right? The character, and then we just learned unsigned binary or unsigned integer, right? They have a range. If you do, like these machines, you're going to have this. On your calculator, on the computer, if you do 4294 plus 967295 plus 1, then you're going to get 0. Okay? Because your computer cannot handle that number. Identical thing, okay? Maybe 20 years ago, you do this plus 1, then you get 0, right? But now the computers got bigger to be able to wider representation. Which is the reason in the textbook that I show you, you see here, it says enter the number. They actually warned you because whatever this textbook is using, the range is limited. Okay? So that's why they have to limit this. Otherwise, the web page is going to break actually, or it's going to give you a wrong answer. That's the whole reason. And when that happens, it's called overflow. Don't think it like it's overflow because large number plus 1. I can have we haven't learned this yet. We have a signed integer, which is negative number to positive number, right? Negative 32768 minus 1 is going to get you 0, that's what I think. We'll practice it later, okay? That's not an underflow. That's also overflow, okay? It's not just over. Like even from the negative number, you add a negative number, it's an overflow, okay? Underflow is something different. That's the concept of an overflow, and that's going to be a core thing because we will actually, much later, you're going to have to tell me whether if you do something, it's going to result in overflow. And then in some C coding, you have to handle this. In C programming, I'm not sure about Java. Python, you can do whatever you want because it's quite fast. I think even in Java, if you do a large number plus large number, I think it's going to give you, well, Java is going to have overflow. Just C and C++. If you add a large number, you get a negative number. That's what happens.
Does that mean you report to error? Or?
It's not an error. It's a program itself. It's detecting. And I will expect you to actually detect it. It's going to be one of the programming quiz that I will ask you. Much later. Overflow, underflow is not an error. It's the program that's basically. All right. Good. Now, I told you how to do a number unsigned. We're going to learn how to do a signed number in binary. Okay, so all right, so we have a signed binary number. That's called two's complement. Okay, so what this means is let me tell you some funny thing. Okay, you only have 0 and 1, and somehow you have to represent a negative number, right? And somebody's going to say, you know what? Okay, let's only go with a 4-digit number. Well, okay, you know what? Make this a sign bit. So if it's 0, it means positive. If it's 1, it's a negative. Okay? So this means this is 1. This is negative 1, right? Why don't we do it like this? That seems like a good way to do it. And we don't do this in any computers, okay? So let's think about y, okay? So first of all, 1 plus minus 1, what are you going to get? No. You can't do a decimal addition. Remember, computer is a binary machine only, so I can only add the bits, right? So I just added this and this, right? And I get this. What's this number? Minus 2. You see the problem? We can't do an addition like this, right? So are you going to make a special calculation to do with this? No, right? That's not. So that's not what we do. Okay? You can see why just putting a bit there makes sense, right? Okay, so that's why we use what's called a two's complement, okay? Two's complement is a way to represent a negative number in an integer in a very nice way. We'll teach you how to. Before I do this, you need to understand a couple of terminology. All right, signed number, unsigned number, okay? So far, I only shown you unsigned numbers up to this, right? Signed number means you have a range. Again, let me go back to that C table. Okay. Can anybody tell me? Okay, let's go with character. This or this. Do you see anything interesting here? How many numbers can you represent?
256.
Right. How many numbers can you represent? 256. Exactly. That's exactly what it is. You have the same 8-bit number, 8-bit representation. You can use it as a signed number, or you can use it as an unsigned number. Okay. Where you see this in a programming language is, if you ever do C programming or C++, or in Java, I think, sometimes, I'm sure you all know, int x equal to 1, right? I'm sure you've seen somewhere, right? This is automatically assigned into, okay? In order to use an unsigned, you have to actually do an unsigned x equal to 1. Why do you want to use unsigned? Well, let's think about it. You can represent, say this, right? Unsigned means, right? Sorry, let's go with 2 bytes. Let's go with the shorts, okay? Because there's an example. Short, you can represent numbers from negative this, right? And unsigned short, you can go this much, right? So you can have a higher boundary on the right side, right? And sometimes you wanted this because there's no point of going negative. So for example, let's think about like a census in your census. Oh, this is so boring. Hold on. Let's think about your bank account deposit, okay? Why you ever want to make an ATM, you can deposit a signed number, right? You know what I mean? Like if I deposit negative 2,000, what does that mean? That's dumb, right? And I can. That's what. Okay, so that's why you want to have a unsigned note because you want to have a higher revenue. Okay, and this is going to cause a trouble in the beginning because think about it. If you think of a banking system like Bank of America, right? Like back in 20 years ago, how many millionaires you had? Like not many, right? So you can get by. But now it's like a lot. Everybody's millionaire. You pretty much need a larger representation, right? So this kind of stuff is why you have to think about it. In real practice, nobody cares you use no unsigned, unless very very special circumstances, right? Like when this is working on business lab or something, okay? But theory-wise, you want to use unsigned number all the time unless you actually need a negative number to represent it, okay? Okay, cool. So that's why. So we have a signed magnitude representation. That's another form of representation. Signed magnitude representation uses left bit for sign and 0 means positive, 1 means negative, which was what I just did, okay? This is not just a bullshit, okay? This is actually one representation called signed magnitude representation, okay? Just it's not used in a computer that we're learning, okay? In this class. Because exactly that reason. Yes.
So how does it represent for negative 1?
Just what sign bit. 1 means negative, 0 means positive. That's it.
Okay.
So if I give you the number like 10000, what does that mean? It is negative 0. If I give you 0000, it is 0. That's another issue.
The last 3 digit was the actual number.
What's that?
Like the last 3 digits was the actual.
It's the actual binary number. So if I do like a 000, it's a 0. 001 is 1, right? 010 is 2, right? And then you use the extra bit to just represent a sign.
What if it exceeds like this 3 digits?
Then you can't do it. That's an overflow. Okay? Anything that exceeds on the lower bound is an overflow. Okay? And then what happens there is called unsigned. Okay? Okay. So we just did this. Okay, let's learn what's called complement. Okay? Complement is easy. Complement is just okay. So I have 101. What's the complement? Whatever gives this 111, okay? When you add it, which is 010, okay? Well, there's a formal definition. I don't even think like this, okay? Just flip it. Just flip all this. 1 becomes 0, 0 becomes 1. That's it, okay? That's a complement, okay? This terminology, okay? If you don't understand this, you shouldn't be here, okay? So, whatever. You can look at this later, but just as complement. This is the reason why I want to talk about this. Now we come to 2's complement, okay? Every one of your computer is using 2's complement to represent a negative number, okay? I am not going to explain this. I'm not going to explain the history about it. I'm just going to tell you how to do it, okay? Because anybody's interested in it. I'm not 2's complement expert either. Way to do 2's complement is, first, let's go with a positive number. I'll convert it into a negative number. All right, so what is number 5? 5 is 101, right? How do you make it negative 5? You have to go through 2's complement process. I told you complement, right? Complement first, which is flip the bits. So 010, right? And 2's complement means just add 1 to it. Okay? So this is, hold on, I messed up something. Wait a second. I messed up something.
0,
I should have
0,
4 digits, yeah. Follow the 3-digit representation, I need 4 digits, yes. And then I flip it, and then add 1 there. This is a negative 5, okay? This is called the two complement process. How do you know a number is a negative or positive? Just like what I told you, look at this bit. This bit tells you it's negative or positive, okay? So, do you get it?
Should that be like if it 1001 is negative 1, right?
1.
001.
That's what? No, it's not negative 1. Actually, that's the question that I was going to ask you. What is negative 1 equal to this?
1, 1, 1, 1.
Exactly, 1, 1, 1, 1 is negative 1. Because, start with a positive number, 0, 0, 0, 1. Complement this, 1, 1, 1, 0. Add 1 to it, which is 1, 1, 1, 1. Okay? Got this? Negative 1. You always start with a number, positive number, flip the bits, add 1, that becomes the 2's complement representation of negative of this number. Okay?
It works the other way around as well now.
Exactly, so let's go with that. I'm going to give you this number. What is this? You have no idea, right? So let's go. Flip this, 0, 0, 1, 0. Add 1, which is, what is this? 3. So what was this number? Negative 3. How do you know negative? Negative, right? That's how 2's complement works. Okay. Now, let's do an addition. Whatever addition we failed, let's try it. Our addition was what? I forgot. It was like a negative 6 plus something?
6 plus 1.
Yeah, negative 6 plus 1, right? So let's go with the negative 6 first. Negative 6 is this, right? And then this is negative 6, right? Okay? So negative 6 plus 1, right? That was the one that we did. We were supposed to be negative 5, right? Negative 6. 1 is that, right?
Yep.
Add it, what are you going to get? 1, 1, 0, 1, right? Well, you know this is a negative number. What number is it? I don't know. So let's do 2's complement. 0, 1, 0, 0. Plus 1. This is 5, right? So you know this number means negative 5, which is correct. You can see why computers use 2's complement. Because it makes the binary calculation super easy. That's why it's a 2's complement. Okay, so moving on to one more thing. Here is one thing that I want to, hold on. So this is another thing that I want you to know. 0, 1, 1, 1 is 7, right? What if I do 7 plus 1? It becomes? What is this? No. This is a sign. It's a negative
Does
number.
that make overflow?
Exactly. So, and then plus 1, what are you going to get?
0,
0.
What is this number then? What was this number? This is exactly what happened. 7 plus 1 becomes negative 8. And that's an overflow. Got it?
But this is very limited though, right?
What?
It's only 8 digit and it's over.
What do you mean?
Like it's like very small range.
So right now we only
I mean,
have
it's
4
a,
digits.
it's a small range, that's why I use it as an example. But you can do the identical thing on the big number that I showed you. Yeah.
So right now we only have 4 digits, but we can like make it longer, like 8 digits and then
8 digits. Still, 8 digits is the same issue.
Yeah, it's always the same issue.
It's an issue with everywhere, right?
Yeah.
You have 8 digit, right? And then you add 1, right? What are you going to get? Same thing. Positive number plus positive number, you get negative number. It's an issue with every single computer, okay? It's an overflow issue. So, that's why.
Isn't 1000 minus 0 instead of minus 8?
Hold on a second, what did you say? This?
Show lines bottom. 1, 1 bottom. 1000 wouldn't shouldn't it be -0 instead of -8?
That's in
Because the first
No,
one
it's
is
a
just a
two's
sign,
complement.
right?
No, hold on. It's a two's complement representation,
Okay, yeah.
not one's complement. Okay. So this number I don't know. You only thing you know at this point is you know there's a negative number,
Yeah.
but I don't know what number it is, right?
Okay.
That's why I do conversion, and I got 8, so I know it's a negative.
Okay.
That's the difference between twos and one's what's the
Question. So when you flip it like from negative 5 to you want to check it for 5, why you add 1? Doesn't it?
Yes.
Yeah, shouldn't be like when you flip it just.
What do you mean? I'm just adding it. That's it. Regular addition.
Yeah, but when you like flip it again, right? You get a number 1011 and you flip it.
1011. What does 1011 mean?
Negative 5.
How do I know this? I have to do this calculation.
Yeah, my question is like you flip it, you want to check it, right? And you flip it 0100 and you add 1. Why would you add 1?
This is some negative number. Okay, so okay. Let me tell you why.
Okay.
What is this number? Decimal. You don't know, right? You know that it's just negative some number, right? How do you get that?
You flipped it?
Yeah, you have to do this process. That's why I'm doing it.
Flip and add 1.
Add 1.
You have to add 1 as well.
Yeah. So what are you gonna get? This is 10, right?
Yeah.
So I know that this number means negative 10. That's why I do it.
Okay. So it just
Yeah, I need to figure out the magnitude. That's all. Okay. So that's that. All right. So let's go into something better. Let's go hexadecimal because when you look at a computer, you're not going to see a binary much because you can see there's too many ones and zeros, right? So the next step we're going to do is hexadecimal. Hexadecimal is base 16, okay? So how do you count? 1, 2, 3, 4, 6, 7, 8, 9, A, B, C, D, E, F. That's it. So let's do an addition real quick. I'm not going to spend too much time because I want you to just practice it. You're not going to get it anyways today. You have to practice it. So let's do this. What's the E plus 9? What are you going to get? E is 14. 9 is 9. So 14 plus 9 is 23, right? How do you represent 23 in hexadecimal? No, it's 1/8. Okay? So hexadecimal representation of 1/8. Same logic as you did it with a binary. Think about it. Why 1/8? The first digit is a hexadecimal representation, right? This is what? You can represent from 1 to 15, right?
Yeah.
And then this is 16, right? And then, right? So, you want to represent, this is what? E plus 9 is 23, right? 23 is 1, and then what's the remainder?
7.
No, sorry. Yeah, 16, right? Sorry, it should be 17. Remainder 7, right? Triple 17. So 17 in hexadecimal means 23 in decimal, okay? That's hexadecimal. Which is the reason why in your computer, if you look at the memory dump, you see a bunch of OF, 0 to whatever, right? Because it's a hexadecimal representation. Hexadecimal representation is very nice, and I'll tell you why. Why hexadecimal is preferred? Because let's do binary representation. Okay, I have a binary representation of. Okay, so unsigned. Okay, let's go unsigned. What does that mean? This is 7. This is 6, right?
Yeah.
No. 8.
9.
9. Okay. 10?
10.
Yeah, 8 plus 2, 10, right? Okay. In order to display these two digits, right, these two Okay. In order to display 7, whatever, in order to represent this in a, to you even on a board, I have to write 4 times, right? 0, 1, 1, 1, and 1, 0, 1, 0, right? Too much, right? 4 digit. How many? What's number range you can represent? What's the largest number you can represent on the 4? 15. You see that the biggest number in hexadecimal is 15, right? So instead of writing 4, let 4 binary numbers, you can actually get by. 7 is 7, 10 is 8. That's it. You can just write like this. That's why it's way easier to use hexadecimal. Okay? So when you do memory dump from your operating system, you're not gonna see 0, 1, 1, 1, 1, 0, 1, 0. You're gonna see 7, 8. Let's get dumped. That's what you're gonna see. Okay?
Any hex can represent any number we want to.
Yeah. Exactly. Hexadecimal is what is actually being printed on your monitor. Almost every one of your machines. Okay. And to show you that memory dump. If you look at any memory dump, do you see that? That's hexadecimal representation of the memory dump. For example. Now you understand what 6.5 means. It's really 6 means 0, 0, 1, 1, 0, right? That's how the memory is stored in your DRAM. And that's what the memory dump means. And it is hexadecimal because it's easier to see this way. Okay.
Oh, Professor.
Yeah.
I want to ask a very dumb question. Like for the example on the board, you said 1010 is 10, but it shouldn't be the first letter to be negative.
I said unsigned number.
Oh, unsigned.
Yeah. So when I give an example, I say it's unsigned. All right. So cool. Let's do that one. That's hexadecimal. So in HTML, which I'm not going to teach, but if you ever know HTML, I think you know the colors, right? Sometimes you put FF, right? FF is red because what does FF? What's the number on FF? No. FF is how many digits? F single letter is a 4-digit, right?
Yeah.
I think 256.
255.
5, right? Right. So FF. So this is 55, right? So 255, right?
Yeah.
And that is because so I click the red, right? I click the red. Do you see that? Hexadecimal. FF is actually 255. Now you understand what FF and all the hexadecimal means, right? It's a very common representation in the computer. Okay? Participation activity, you do it, I'm not going to do it, okay? I'm going to do one exercise on the octal number, but I want you to practice it later. Alright, so unsigned, okay? Let's go with unsigned again. Octal number is, you only have 8 digits, right? Which is 0 to 7. So let's do the octal number addition of 12 plus 6. And this is octal number addition. What do you think is going to be the answer to this? Oh no, this is easy. Let's go. Too easy. Octal, right? Alright, let's go with the 17 plus 7. Unsigned octal. What are you going to get? Try it. It's kind of fun.
Is it 26?
Okay.
26.
Hold on. let's this one is this is a number. 17 is not 17, right? 17 is this digit means octal. So one, this is 1. That means this is 8, and this means 7. So actually, 17 means 15 in decimal, right? And 77, right? You add that, you're gonna get 22, right? So answer here must be 22 in decimal, but we have to represent it in octal, right? So octal is, this digit means 7, right? And this one is going to be 8, right? If I put here, that's 8, right? If I put 2, that's 16, right? So 22 minus 16, what do you get? 26. That's it. Yeah.
Why 17 is 15 in hexadecimal?
Because
15 was
17, hold on, 17, right?
yeah.
So 7 is 7, you don't care, right? 1, this is in the second digit, 10th digit, right? So let's count. Octal. 0, 1, 2, 3, 4, 5, 6, 7. I don't have any more digits. Octal, I only have 8. How do I represent 8 then? Next one, 1 0, just like the convention we followed, right? 17 means whatever, this 8 plus 7, right? That's how I get 50. Got it?
So I have more questions. We already have hexadecimal. Why we need octal again?
We wanna have octal again.
Yeah, because we already have hexadecimal to represent the number.
Oh, why we need octal?
Yeah.
We don't need octal. Just for the sake of practice. You have to know how to work. That's all. Computer uses binary and hexadecimal. Octal is not used. Okay, so I think this is fine. I just went over this. Okay. We're gonna go with the floating point, but let's take a break. Okay, let's take a 10-minute break and then let's go. Just remember, every day I'm finishing the lecture at sometime around 5 to 10. Okay. So but today this is the last chapter that I'm gonna cover, but this is completely different from what we covered. So what time is it? Get back by 5 o'clock. Okay.
I feel confused too.
How to represent a integer 40 to 0 and 95, but what are you going to do with like a 96.6? This is actually a quite important discussion in computer. And I think you know that floating point numbers are commonly used in that notation like that times 10 to the power 1 or 1.0 times 10 to the negative 4 and things like that, right? So if you look at this, you can see it has a digit, plus minus something, and then you have a decimal number, a decimal point, and there's a fractional part times 10 to the power, right? That's a common form. Every scientific notation is 1 digit dot fractional part times 10 to the power something, right? All right, so that is the scientific notation, and then you have to know the terms, significant, and then exponent, okay? So two parts of scientific notation you have to know is significant times exponents, right? Well, I'm not going to do it. Significant here is 10 to the power, This is represented as 1.67479 times 10 to the power of 2, right? So that's how you do it, and then the significant is whatever that is, and the exponent is 2, right? So that is how we process the thing, right? Well, now we're a little different because we are doing the floating point in a binary number format, okay? So we call the dot because that's a decimal point, right? Well, we're not dealing with a decimal anymore. We're dealing with a binary. It's called a binary point, okay? So it's not like 1 point. I mean, I'm still gonna call it 1 point something, right? But it's not decimal. It's a binary point. and another term is called red exponent. So decimal is dot 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 and this, right? Binary is, take a look, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0, dot, 2 to the power of -1, -2, -3, -4, okay? So let me explain this in a better, easier way. Okay, let me write 1.25 in a binary format, okay? So take a look at this. I'm going to write this in a binary format, okay? 1.25. How do I do this? Easy. 1 is 1, right? That 0.25 is 1 over 4, right? So 1 over 4 is equal to 2 to the power of -2, right? So what's going to have 1 point? This one is 2 to the power of -1. I don't use it, right? The next one is 2 to the power of -2, right? There. Good. There. 1.01 is a binary representation of 1.25. Okay? So again, easy representation. That's easy. We're gonna go into that's an easy floating point format. Now we're going to go into the floating point format of much more complicated one here, okay? So right now, let's go with this. 32-bit. Just like this. Bit number 31 is a sign bit, okay? Bit number 30, 29, 28, whatever, to 23 is an exponent, okay? So this number here represent, hold on. This number here represents exponent here, okay? But it's not regular exponents, by the way. I'll explain this a little later. And then this portion here is significant, okay? So let's play this. Representing 8 is a plus with 1 and that. Okay. Hold on. Let me do the Hold on. I'll do it. Good. Let me explain what just happened, okay? So the way the computers use a floating point is a little different. The first one was 8, right? I want to represent 8 in 32-bit number. 8. 8 is basically 8.0, right? Times 10 to the power of what? 0, right? Okay, that's our decimal representation. 8.0 times 10 to the power of 0, right? Okay, it's a positive number, so the sign bit is 0, right? Now, forget the exponents. Let's go to the significant, okay? Significant becomes bit number 22 to all the way to 0, right? I want 8, so it's going to be 1000, right? 1000, right? 1, 2, 4, 8, right? And everything fills up with 0, right? Now, let me tell you what interesting thing about exponent. It's not exponent is exponent here, okay? We use something called the bias. And bias in IEEE representation is 127. So every number you get here, right? You have to subtract by 127. Okay, my question is, your end goal is 0, right? That's the exponents, right? Whatever you're getting from the exponents, you got a minus 127, you're going to get 0. What number do you want? 127, right? What is 127 in binary representation? It is hold on. They messed up.
Any more ones, I guess?
Hold on. I messed up. No, hold on. This is not that representation. Hold on, I think I did it wrong. Wait. Just forget everything I said. What? Oh, forget it. Okay, no, hold on. Sorry, my bad. I was teaching you something else. Sorry, let me do again. I did not take the slide went straight to the attributes. So, my bad. So in order to do 8.0 in a scientific representation, in a binary form, you gotta go with a base of 2 first, right? So it's a base 2 to the power of 3, right?
Yeah.
And that's the exponent, right?
Yeah.
So that's why in this representation you have to make 3, right? I mean it's a 1 times whatever because what do you call it? It's a 1 times that because this itself is 8, right?
Yeah.
So hold on. That you get 8, right? Okay, so we're gonna represent this in a binary format. Not binary format. In a binary floating point representative format. The sign bit is gonna be 0 because it's a positive number, right? That's the sign bit 0, right?
Yeah.
And then we're gonna achieve something minus 127 equal to 3, right? So that's gonna be 130, right?
Yeah.
So 130 is gonna be 0, 1, 4, 8, 16, 30, 64, 128. That's it. 120 plus 2 is 130, right? So how many bits do you have here? 1, 2, 3, 4, 5, 6, 7, 8 bits, right? So 2, 4, 6, 8 bits. That's it. Yeah. 0, 1, 0, 0. Yeah, that's it. So you got this point, and then this one is you gotta get a significant, right? It's 1 point something. So what are you gonna get? You're just gonna do all zeros. Hold on. Let me just tell you what. Okay, hold on. Do you see this 1 here? That's gray. You can't see it. It's not black. Okay.
Oh,
You actually don't have 0 there. But the thing is, it's assumed to be 1, no matter what. And here's the rationale. Okay, you know what? This is the representation of some floating point number, right? Can you ever have 0.23 or 0 point something something? You never, right?
No.
What if we have a 0.2 times 10 to the negative 2 to the power of 4? It is wrong because scientific notation you're supposed to have 2.0 times. You know what I mean? You cannot start with a 0, right? You always have a number 1. So it should be 2, but it's a binary number. Okay, I messed up. You understand what I mean? You always have a number here in front of the dot, right? You cannot have a 0 point something, right? This is not possible, right? It is not a correct scientific notation, right? So that's why it is assumed that you are going to have a 1 point something something something, okay? That's why the 1 is assumed and you never write it, but it's assumed that you're going to have a 1 there, okay? How do you represent the 20? Negative 20, right? I think I will stop here because it is a little difficult to do a thing. I'll do it next week, okay? What I'm saying is understand up to here, okay? The regular floating point representation. Let me cover the IEEE floating point. Because IEEE floating point itself is quite a difficult topic. And it's already 5:13. Go up to, hold on. 30 up to 5 points, okay? And that's not the quiz coverage. But for homework, I will assign all the way up to the end of 1.6. I'll review 1.6 again, but you're not going to be tested on this floating point stuff. I will post homework 1 tonight. I don't know when I'm going to go home and eat dinner. But once you purchase it, I think you can unlock the whole thing. Okay?
Just do it tomorrow.
Up to you, I don't really care, because deadline is going to be Wednesday, 11:59 Wednesday next week, okay? Before I let you go, any questions about the course logistics? All clear?
So, if we're gonna have quiz, it's gonna be something similar of things that we saw on the.
Yes, it's going to be almost whatever's on the homework, yeah.
So we can finish all the challenges
You have to finish it.
all like that.
Whether you get correct or not, they don't care. Well, actually, they do care. But you can try multiple times. You know what I mean? You get it wrong, they'll tell you. I mean, that's why I know I got it correct, right? But you get it wrong, you have to do it again. Okay. And just letting you know, homework 1 has 202 points. Okay. So it has quite a bit of activity, but it's quite easy as you can see. That's all for today. I think I'll let you go, and I'll see you next week.
Thank you.
See you on Tuesday.